Hello my dear students, welcome back to my channel Essential Academy Chemistry with Vinay. In this video, we are going to learn about the quantum numbers. What are the different types of questions that have been asked in the previous year's Neet examination? We are also going to solve some of the questions where you can just see here children. So, if we learn quantum numbers, what is the importance? What are the different types of questions that you can see in your examination? That's what I'm going to just tell you about that information also in this video. Definitely children, this video is going to be very much helpful for you to solve many of the different types of questions that is based on quantum numbers. Yes children, let us first know what are quantum numbers. How to take the values of quantum numbers. In quantum numbers, there are four types of quantum numbers: principal quantum number, azimuthal quantum number, magnetic quantum number, spin quantum number. Children, it is very easy to understand quantum numbers. I'll make it very simple, you can understand it. Let me first tell you. Let me take an example of this, that is 2s. In 2s, 2, what is this 2? 2 is principal quantum number, which is a shell. What is this s? S is a subshell and that is a azimuthal quantum number. And when it comes to s, it has got one orbital. In this orbital is nothing but magnetic quantum number. The electrons what we fill inside this orbital, that will be in opposite spin, and that is going to be spin quantum number. Once again, I'll just tell you children, this 2, in this 2s, 2 is the principal quantum number, which is a shell. The subshell, that is s, is going to be what? Azimuthal quantum number. The magnetic quantum number, that is nothing, the orbital, what you see, the orbital is a magnetic quantum number. The electron that you see inside the orbital, that is a spin quantum number. Hope you have understood with the help of this example what is a principal quantum number, azimuthal quantum number, magnetic quantum number, spin quantum number. Now let us learn how to get the values of quantum number of these examples which has been given here. First one is 2s. I just told you that 2 will be the principal quantum number which is represented as n. Here 3 is the principal quantum number. Here 4 is the principal quantum number. Here 5 is the principal quantum number. I hope now it is understood what will be the principal quantum number. And it is represented by n. Now let us see how to take the value of azimuthal quantum number. Azimuthal quantum number is represented by L. For S, the azimuthal quantum number will be 0. For P, the azimuthal quantum number will be 1. For D, the azimuthal quantum number will be 2. For F, the azimuthal quantum number will be 3. We will make use of this value again and again to solve the questions children. Remember. Then we have magnetic quantum number. If you see 0, if the value of azimuthal quantum number is 0, that is for s orbital, then it is going to be what? I have got one orbital, I will take 0. If it is 1 for p orbital, how many orbitals are you going to take? We are going to take 3 orbitals. At the center, I'll just take it as 0. On the other side, I'll just take it as -1. This side, I'll just take it as +1. So there are 3 numbers that you get. If I take for D, you can observe here. For D, how many orbitals are we going to take? We are going to take 5 orbitals. At the center, I'll start with 0. This becomes -1, this is +1, this is +2, this is -2. If it is F orbital, you know that we will take how many orbitals? We will take 7 orbitals. We will take 7 orbitals. So at the center, At the center, I'll take this orbital as 0. This will become plus 1, plus 2, plus 3. This is minus 1, minus 2, minus 3. So this will be the value of M for S, P, D and F orbital. This is F orbital. F it is, children. F. Now you can observe what will be the spin. That is spin. That is nothing but the number of electrons that is going to be filling into the orbital. If it goes up, then the direction is up, then it is plus of. If it is coming downwards, then it is the minus of. And this is how we can take the value of quantum numbers of the given examples, which is very, very important, children. If you know this, you can solve many of the questions. Children, you can observe here, if you know how to find the quantum numbers of the examples given, then what are the questions that is going to be related or connected to quantum numbers? You can come to this side. You can easily find the number of electrons in a shell by using the formula 2n square. You can easily find the number of orbitals present by using the formula n square. If you know the quantum numbers, you can also find angular nodes, that is always equal to azimuthal quantum number. There is one more, number of radial nodes, that is n minus L minus 1, where n is a principal quantum number, L is a azimuthal quantum number. This formula is very important, children, to find the number of radial nodes. If you have got the quantum numbers, you can also solve the question, that is n plus L rule, where you can find the number of orbitals. If quantum number is known well, you can also solve the questions that is based on M value, based on the shapes of the atomic orbitals, especially the shapes of p orbital, the shapes of d orbitals will give you a lot of questions. Now let us solve some of the questions. At the same time, let us also know I have made one more chart especially for the M value that is based on the shapes of the atomic orbital. I'll just share that chart first and then we will solve the questions. Here is that trick box, children, which will help you to know the value of M that is based on the shape of orbitals. If you observe here, in the shape of orbitals, the most important one is the p and d orbital. I have also given you, in case of s orbital, the shape is spherical. In case of p orbital, the shape is dumbbell shape. In case of d orbital, the shape is double dumbbell shape. A very important information you should remember, children, that double dumbbell shape is only possible, it is not possible for dz square. It is only a dumbbell shape. Whereas for all the orbitals of d orbitals, it has got the double dumbbell shape. Remember, children, in case of d orbitals, there are 5 d orbitals. In that, 4 d orbitals will have a dumbbell shape, that is px, dxy, dx square minus y square, dz, dxz, dyz. Remember, I am just showing you here all these 4 orbitals which you are seeing here, they all will have double dumbbell shape. Whereas the only one except dz square, it does not have a double dumbbell shape, which is a very important information you should know, children. You can observe here the L values. You can observe here L is equal to 0 for s orbital, L is equal to 1 for p orbital, L is equal to 2 for d. In the same way, L is equal to 3 for f orbital. You can observe here, I have listed out the M value for 2px, it is 1. That is for 2py, it is plus or minus 1. Whereas for 2pz, that you need to remember, it is M is equal to 0. The magnetic number, that is M value for 2px, 2py, 2pz. Remember, for 2pz, it is 0. Then again, you can observe here, the M value for dxy, it is M plus or minus 2. Even for dx square minus y square, the M value is plus or minus 2. Whereas in case of dxy, dyz, where you can observe the M value will be plus or minus 1. Whereas for dz square, you can observe the value of M is 0. The value of m is 0, children. Now you can observe here, this is also a very important information where the question can be based on this information. What is it? For dxy, for dyz, for dzx, the orientation of the orbital will be between the axis, children. The between the axis takes place. Whereas the orientation of the orbitals in case of dx square minus y square and in dz square, it will be oriented along the axis. Information about this I have uploaded my previous video. You'll get the complete picture what is this statement is. Yes, children, let us solve the first question. You can observe this question, children. The total number of orbitals present for principal quantum number when n is equal to 4. I had told you there are two formulas. One is to find the total number of electrons that is going to be present in the orbital, that we use the formula 2n square. Whereas here they are asking you to find the total number of orbitals. The number of orbitals can be calculated by the formula n square. Here n is equal to 4, therefore it's very simple, that is 4 square, there it is 4 fours are, it is 16. Therefore option D is the correct answer. Hope it was a very easy question. We'll go for the next question now. Yes, children, let us solve the next question. How many electrons can fit in orbital for which n is equal to 3, L is equal to 1? This question was asked in the Neet 2016, children. Remember this question, there is a twist in this question that you need to understand the question properly, children. They are asking only in the orbital. So let us see, if n is equal to 3, n is equal to 3, L is equal to 1. If the value of L is equal to 1, then it is 3p. Remember, then it is 3p. For p orbitals, you will have 3 orbitals. For p, you will just draw 3. In one orbital, how many electrons is it possible? In one orbital, we can place only 2 electrons. That is why option 2 is the correct answer. Hope you have understood this question, and here they are asking you orbital. In one orbital of this n is equal to 3 and L is equal to 1, how many electrons? It is only 2 electrons. Next we'll move on to the next question. This is the third question, children. The number of angular nodes and radial nodes in 3s orbital. This was the question which was asked in Neet 2020. Let us find the answer. So I have already told you there is a formula, that is angular nodes is equal to angular nodes, that is equal to L, that is azimuthal quantum number. For the radial nodes, to find the radial nodes, we have a formula n minus L, that is minus of 1. So let us know by the value 3s. Here 3 is what? N is equal to 3, that is principal quantum number. And what is this s? S is going to give you the L value. L is going to be what? 0. So when n is equal to 3, L is equal to 0, what is L? L is 0. Therefore L will be 0. And what is the next value? In 0 as an option C also there is 0, as well as D also 0. Therefore any of these two options will be the correct answer. Let me go for the next. I'll apply the formula. N is what? N is 3 minus, what is L? L is how much? L is 0 minus 1. Therefore how much it is? It is 2. So here the radial node is 2 and angular node is 0, that is 0 and 2. Therefore option D has got 0 and 2 respectively. Hope you have understood this question also, which was based on angular nodes and radial nodes. Do remember the formula, children. The last question in this video, which one is a wrong statement, children? Remember, they are asking the wrong statement. dxy orbital is oriented between the axis S. It is going to orient between the axis. Just now I showed you in that chart. Increase in n increases the energy of orbital. Yes, it is also a correct statement. value of m for dz square is plus or minus 1, whereas here the option C, children, the value of m is 0 for dz square. I hope you remember this. For dz square as well as for 2pz, the value of m is what? The value of m is 0, whereas here they have given plus or minus 1. Therefore, the wrong statement here is value of m for dz square is plus or minus 1. Hope you have understood this question also. Let us see the fourth option. Shape of dx square minus y square is a double dumbbell shape. Yes, this is also a correct option. The wrong statement here is option C, that is dz square is plus or minus 1 m value. Hope you have understood this, and this video, I hope you liked it and you have understand the concepts as well as the questions that can be coming from the quantum numbers. For my next video, you will get the concepts of the other question, that is ionization potential, ionization energy. For more videos, subscribe for my channel and click on the bell icon, children. See you again in my next video.